Welcome back. Let's resume. We talked about problem 1 in the first video, so let's talk about the second problem, which is a backward problem. Here we go. We are given the cumulative distribution function, and from this we have to find out the probability mass function, and this probability, the expected value, and finally the probability standard deviation. The important part is the mass function. Once you find the mass function, then you can use the exact same method that you used in problem 1 to answer the next 3 questions easily. The hard part is a mass function. Now, how do you do that? Well, let's answer that question in 3-step process. Well, instead of 3-step, as a matter of fact, this is 2-step process. Step 0 is preparation. Just a color coding, as a matter of fact. Here, do you see the breaking points? The x values where the jump takes place. In order to answer that question, you should not be looking at the left-hand side. In the previous video, I emphasized many times it's the right-hand side that is important. The same applies here. That's what you should be looking at. At which numerical value we have a jump from the first to second, second to third, third to fourth line, and finally fourth to fifth line. Well, here's the answer. See, I color-coded. At x equals -2, we have a jump from the first line to second line. At x equal to 1.5, the blue, we have a jump from 0.3 to 0.85, and so on. So this color coding really helps you seeing this jump. It's just a preparation. Next, let's go to the step 1 of determining the mass function. The jump position. What are the x values? Well, here they are, -2, 1.5, +2, and 3.25, and those become the first line. Those are possible x values from smallest to largest. Now, what are the probabilities? You have to fill these question marks. Well, okay, let's go back to this with color coding. At x equals to -2, from first line to second line, the cumulative probability used to be 0. Something was added and became 0.3. What did he just add? Second question. From second line to third line, the cumulative probability used to be 0.3. We just added something and ended up with 0.85. What did you just add? Repeat that question 2 more times. From 0.85 to 0.9, what did you add? From 0.9 to 1.0, what did you just add? Answers to these questions will fill up this line, this second line, and here's the answer. We have appropriate subtractions. Surprising? No, probably not, because the previous process was accumulation, cumulative probability. So accumulation was repeated addition. So going back, we need subtraction. It's not surprising at all. Now, once you determine the mass function, the other sub-problems are easy to handle. Here we go. This is the mass function we just determined in the previous part, and the probability for x value taking value strictly greater than 1, less than or equal to 2. So we are looking at these two possibilities. So we'd add up these two. we get this probability. Next, let's find out the expected value. Well, this is a mass function, and what did he do? We multiply x times p, multiply x times p, multiply x times p, multiply x times p, and add them all up. And here we go. For some reason, I have p times x here, first p times first x, second p times second x, and so on. But that's okay, multiplication is commutative. So mu is 0.65. Using that, let's find out the standard deviation. What's the standard deviation? This is first deviation. First x value minus mu squared. This is the second deviation. Second x value minus mu squared, and so on and so forth. And each one times the probability. And so on. Run your calculator, you get the variance. Taking the square root, you get the standard deviation. In short, once you find the mass function, the next questions are easier, much easier. Let's go back to problem 1. Problem 1, subproblem 1 to 3 were easy. The last one was the hardest, wasn't it? Getting cumulative distribution function from the mass function. Problem 2, the very first part is the hardest. Once you have the mass function, the others are all easy, but the very first step is difficult, so a lot of students end up screwing up in the very first part, and that can be a little bit devastating, but can't be helped. Both problems are important. Both problems 1 and problem 2 are important types of problems, especially the mass function and cumulative distribution function going back and forth, back and forth. Please expect at least one, maybe more in exams. Okay, we have enough time for problem 3. I must admit, problem 3 is relatively less important for this course, but I'm not going to completely remove it out of the picture as well. I must admit that the probability that, some pun intended, that I write this kind of problem in the exam is relatively low, but not zero. Anyway, here we go. From the earlier problem 1, 10 balls are selected with replacement. What exactly does it mean by with replacement? That means select one ball at random, select one, and then record its color and put it back in, shuffle it, and repeat this process. Total 10 times. So because I'm putting this ball back in after recording its color, I can repeat it not just 10 times but 100 times. If we do not replace, then I cannot get any more than 10 balls out of an urn that has only 10 balls, but with replacement I can do it forever. So this problem is about with replacement. In that case, the second row, third row, or 15th row, they're all equivalent. We have same number of balls and same color distribution, same kind of uncertainty. So they are all identical, all independent. In that case, we have this formula, binomial distribution formula. Well, here's a little bit further explanation of binomial formula, but for interested students only. I mean, this kind of expression is rather intimidating. So let's just stick to this formula. What exactly does it mean by n here? That's total number of selection. In this case, we are selecting 10 times. So in this case, n is 10. And its probability is either red or blue, and then 4 or less somehow I'm not getting the correct symbol. Okay, 4 or less for 3.1, or more than 4 for 3.2. That's the structure of this problem. Okay, here's the answer key for 3.1. 4 or less red balls. How does that work? Here it is. 4 less means no red ball, 1 red ball, 2 red balls, 3 red balls, or 4 red balls. Those 5 cases all put together. And each of those 5 cases follow this binomial formula. N choose k, 10 choose 0 in this case, and then 4/10 probability for red is 4/10 to the 0 power because no red, and then the other 10 times all the other non-red, 6/10 to the 10th power. This is 1 red, 10 choose 1, and then 4/10 took place once, and the other case 6/10 took place now 10 minus 1 9 times. This is 2 red, 10 choose 2, and 4/10 to the 2nd power because there are 2 reds this time, and consequently 10 minus 2 is 8, so non-red took place 8 times. So this part, all these parts correspond to this part over here. And what about this n choose k? It is n factorial over k factorial times n minus k factorial, which is well, n times n minus 1 times n minus 2 all the way up to 1. Here k times k minus 1 times k minus 2 all the way up to 1. And this one, n minus k times n minus k minus 1 times and so on all the way up to 1. In short, this is very, very unpleasant computation if you use handheld calculator. So in this kind of problem, I do not expect any more than this one. This is the final form. If you do use advanced calculator, then you can get this kind of computation done. But as I said, I'm not going to write this kind of thing in the exam. It's too cumbersome to calculate with handheld calculator. This is the final form. Well, here in this notebook, I did do the computation. And by the way, I can use this kind of mathematical command to do the computation more effectively. Next, 3.2. More than 4 blue balls, which means 5, 6, 7, all the way up to 10 blue balls added up. Probability for blue is 3/10, and as usual, as before, I'm selecting 10 times. And then here is the first probability, 5 blue balls. So 10 choose 5, and 5 times 3/10 of blue took place, and the other 5 times non-blue. 6 times we have blue, and the other 4 times non-blue, and so on and so forth. 7, 8, 9, and then this one all 10 blue, and non-blue 10 minus 10, so 0 power. This line is the final form of this problem. If you do calculate, you're going to get this kind of number, but I do not require computation. By the way, this is only more effective computation done through mathematical command. You can just type those into Wolfram Alpha and you're going to get cumulative computation like this. Okay, so much for chapter 3. Excuse me, so much for problem 3. And that's about it. I must admit there is relatively little chance that I'm gonna write problem like this in the exam. I mean binomial problem like this in the exam. But that probability may be low, it's not zero. Now as for problem 1, this kind of problem or backwards problem like this, very high probability that you will see. As a matter of fact, either problem 1 or problem 2, either one of them, there's almost 100% of chance you're going to see in the exam. Sometimes I write both of them in the exam, but at least one I always write. I cannot say the same thing to problem 3. That's relatively less important.